Okay, so we still have about a half hour than any potential water cooler. I will have to drop at the top of the hour for any water cooler, but Sarah will stay on to keep the Zoom going. So we have Henrik from Autodesk here. Henrik needs no introduction at all. Of course, we know him quite well. And then at SIGGRAPH just a few weeks ago, as part of our BOF, he gave a great update on all things PBR materials, OpenPBR, MaterialX, glTF PBR. And I think we're seeing a lot of folks rallying around MaterialX, a lot of efforts on some convergence here. Certainly a lot more work to be done, but let's get an update from Henrik. So Henrik, I'll stop the screen share and all you.
All right, thanks, Patrick. Yeah, so yeah, this was a talk I gave at the Birds of a Feather at SIGGRAPH. So it was for a pretty diverse audience. So we did a raise of hands earlier, like in the beginning of the session, and a lot of people that were not like very familiar with USD and glTF and so on. So some of the slides here are going to be very basic for this group, so I'll go through them quickly. But yeah, we got some good feedback on that session. So Patrick asked me to do a repeat basically of what I presented there. I did extend the content a little bit with some things that I found pretty topics that we discussed a lot at SIGGRAPH. So of course this is well known to the people in this audience, but it is useful when we go through all these different formats that we think about the different workflows they've been designed to facilitate. So we need to differentiate between authoring and delivery, and also runtime environments. In authoring, of course, we're talking about the source of truth data. Everything is editable. Typically, we have multiple users from multiple different teams collaborating on the same project. It could be in real time, but typically it's asynchronously. You might have a project that runs from for a year or even in multiple years, and you have several people and teams collaborating on the same project. So USD and MaterialX comes kind of from those types of workflows and trying to facilitate them well. Whereas in the delivery workflows, we're talking about some derived form of the data where you bake things down. Of course, there's nothing that prohibits you from editing, but the assumption is that you won't necessarily edit everything. So let's say material and light parameters you might edit, but not necessarily kind of the vertex mesh data and textures and things like that. And these, in these cases, you want to optimize for transmission, and that's where glTF comes from, and by extension, the glTF PBR model. Then you also have runtime environments, so game engines and web viewers and so on. They might have their own representation of both the scene data and also the materials, depending on their needs. But just to kind of set the context there, that there are different workflows with different needs, and the different solutions that we have been designed to optimize for some of those workflows, but not necessarily all of them. So USD is of course well known to this group. It really shines when it comes to collaboration, the layers and variants and non-destructive overrides. It's very extensible with custom schemas and file formats and asset resolvers and so on. It also have the Hydra rendering framework. So OpenUSD is much more than just a file format. glTF, the slogan from the very start has been the JPEG of 3D. I think that's still holds up really well. It's a good way to think about it. It's really compact to transmit, simple and fast to load. It is also extensible, maybe not to the same extent as something like USD. So when it comes to the authoring workflows, there seems to be a lot of consensus now in the industry, right? We are aligning around USD and MaterialX. So USD for the whole scene description, and then MaterialX specifically for the materials. And you've seen similar slides from many different companies, Autodesk, Adobe, Apple, and others. And this really allows us to exchange 3D scenes between any tool from any vendor, and do that in authoring workflows where multiple users are editing multiple aspects of the project. So back to MaterialX, we've had share outs on MaterialX earlier in this group, so I think most people are familiar with it, but just a quick recap here. You know, it's an open source project that originally came from Lucasfilm and ILM. It was open source in 2017, but for the last few years, it's been governed under the Academy of Software Foundation, so it's now open to participants from you know, any company or any individual that wants to contribute to MaterialX. It's an expressive, flexible graph-based material system that describes the intent of the materials and not necessarily the implementation, which makes it different from some of the previous solutions we've had that are more shading language-based, that are more opinionated on, you know, the implementation of the materials. It's obviously render agnostic, so you can render your materials in any render, whether it's offline or real time. But one important aspect is the authoring tool, also being authoring tool agnostic. So as long as your authoring tool or your material editor understands MaterialX, you can present the materials to the user in their native editing environment and exchange that between different tools. And yeah, that's not necessarily possible with, you know, shading languages, since you don't really, you know, pretty much every material editor is graph based, and by using MaterialX, you can transport those graphs between different editing tools. The three main parts of MaterialX is you have the pattern graphs that describes the input to your shading model. So that could be image nodes or math nodes that describe any sort of procedural texturing that drives color, roughness, IR, and other parameters. Then you have a PBR shading graph that expresses your shading model, and, you know, MaterialX can express all the commonly used shading models from, you know, auto standard surface, glTF PBR, OpenPBR, and so on. And there is also a shader generation framework in MaterialX that can help implementers use MaterialX in your engine, but that's kind of optional. Some engines use it, some have their own shader generation, just traversing the graphs and generating the code. But it is there for people who want to you know, easily get up and running with MaterialX in your engine. And it supports all the common shading languages. One thing that I wanted to expand a little bit more on is the shader translation graph. So that's another concept within MaterialX that's been used for quite some time. So we've used it extensively for a number of years at Autodesk. I know Lucasfilm and ILM are using it internally as well. And it's really a graph that expresses the mapping from one shading model to another shading model. And you can see that on the right-hand side there. In MaterialX right now, there are 4 mappings available there between some of the different shading models: OpenPBR to standard surface to glTF PBR, standard surface to OpenPBR, and then standard surface to USD previous surface. And I think Nick Porcino pointed out there's no glTF to standard surface or OpenPBR, so I think that would be a great addition to kind of complete those workflows. And then maybe you want to collapse some of these as well, so you can go directly from OpenPBR to glTF. But obviously you can chain these together in your node graph if you want to translate between different, you know, go from OpenPBR to standard surface to glTF is doable today. So I had a number of conversations around SIGGRAPH, around shaded translation graphs, and it turns out that IKEA is using that extensively internally. So Johan Bovald from IKEA graciously provided a couple of examples on how they use this. The example material here is a publicly available one. It's from the AMD OpenGPU MaterialX library that you can find the link there on this page. So what we see here is standard surface is rendered in IKEA's Stråla material editor, using a path tracer. So that's OSL test shade that they've modified a bit so they can render their swatch scenes. And the shading graph for standard surface here, you know, the left-hand side here, you have, you know, the inputs to the shading model, and then you have standard surface here on the right-hand side. And if you want to translate this now to glTF PBR, you can just plug in the node that I showed on the previous slide, standard surface to glTF PBR, and that, you know, maps all these input parameters from standard surface to the glTF PBR node. So this is a very convenient way to maintain these mappings, especially as some of these chaining models are evolving. So glTF PBR is not fixed in time, but as long as we keep these mappings up to date, it makes it quite easy to map between different chaining models. So at Autodesk, we use this in several parts of our pipeline. So we have shader translation graphs from some of our old legacy proprietary material models that kind of maps them to standard surface, and we use standard surface internally for all our interop workflows. And then we have another shader translation graph that can map to either glTF PBR or to USD preview surface for USDZ export. So I talked a lot about standard surface because that's the PBR model that is kind of most widespread right now. Oh, sorry, let me finish up the key example here. So with this translation graph, you can kind of see the result here on the right. On the left-hand side, you have what I showed earlier, standard surface path traced. And then when you map to glTF, the path trace results in OSL test shade in the middle. And you can show it in, the glTF sample viewer. And, for this particular material, you get, pretty consistent appearance, of course. So like I mentioned, I talked a lot about standard surface, and that's been, shading model that's been adopted by most of the DCCs in the industry. But last year at SIGGRAPH, we announced this initiative, OpenPBR, that it was started between Autodesk and Adobe to merge Autodesk standard surface with Adobe standard material, and then also move it under neutral governance under Academy Software Foundation. So earlier this spring, we released 1.0 of that specification around SIGGRAPH. It was a 1.1 revision. So this is just getting rolled out. There's not a whole lot of support in DCCs yet because it's brand new, but the desire is to kind of migrate from standard surface to OpenPBR over time. And again, this is something that is under ASWF. It's open for everyone to participate and contribute to. So it's not something that is governed by, one company or a small set of companies. So OpenPBR has the same principles as what standard surface had. It's a very incremental evolution, but there were some great things with Adobe standard material that was incorporated into OpenPBR, and then there was also some new research that wasn't part of either standard surface or Adobe standard material that made sense to incorporate here. So it's still evolving, and it's probably going to take a couple of years before all the DCCs have full support for OpenPBR. But again, it's just like the other shading models, it's portable from high-end offline to real-time engines. But one question that has come up a bit is, how can we make sure that real-time implementations of OpenPBR are somewhat consistent? Because, it is a specification, it leaves all the implementations details up to the implementer. And for offline rendering or even real-time path tracers, this is probably not a big concern because you can implement most of the specification without any compromises. But for real-time engines, especially when it comes to transmission and refraction and subsurface scattering and things like that, if everyone has the kind of their own approximation of that, it does limit the consistency of the appearance between different real-time tools. Just a quick timeline of how this kind of evolved, but again, it goes back to an evolution of the previous shading model, standard surface, and the Adobe standard material. But we started this project November 22, trying to align the two specifications, and it was publicly released end of last year, and then the 1.0 and now the 1.1 release is out. Yeah, you can just go to openpbr.org and find the specification there. And there was a town hall on the open source days just before SIGGRAPH on MaterialX and OpenPBR. So there there's a whole lot more details on both MaterialX and OpenPBR and what the recent advancements are. So if you're interested in that, you can find it on their YouTube channel, or just use the QR code there. Now, so back to the Kronos glTF PBR. So Again, coming with a kind of design principles for glTF and focusing on delivery and you know, portability, and also glTF being very commonly used in e-commerce, and the need for, you know, consistent appearance across different viewers and different platforms. We did take a much more incremental approach in expanding the PBR model for glTF. So here's an overview of the timeline and how the different features have evolved. But you know, there was a lot of considerations going into adding all these features to make sure that they are, you know, well established, and like there are well established ways to implement them, and is feasible to implement them in real-time engines. And so yeah, the approach taken here is quite different from the one with OpenPBR. So there are pros and cons to each one, I would say. And there is like I mentioned earlier, there is a MaterialX node graph that represents the glTF PBR model, which can be used for interop and mapping between different shading models. It's not the one that is in the MaterialX repo is not fully up to date to the latest extensions for glTF PBR. So and that's on the in the plans to update that to make sure it covers the latest. Another development that I think I mentioned before is that we are looking to extend glTF to support procedural textures, and using MaterialX as the way to describe those procedurals. There was some concerns initially, and some people felt like, okay, that might be more on the authoring side than delivery side, but the reality is that with procedural textures, you can often get much higher texture fidelity with a smaller memory footprint. So that fits well with the kind of goals of glTF and being, you know, fast to load and you know, low file size and so on, or small file size. So that is something that is in development. There are two proposed extensions still in draft form, but there's a KHR texture procedurals that adds the ability to express procedures in a more general form, and then you have a second extension that builds on top of that expresses the particular nodes that you have in the MaterialX 139 specification. So this is a pretty interesting development, and again, it has some nice benefits when it comes to the delivery aspects of glTF. But also it obviously helps with some of the interop that you can actually transfer some of the procedural graphs that you have in MaterialX all the way through the delivery side of things. So before we go into the Q&A or the discussion, rather, MaterialX really provides, you know, a very flexible and comprehensive way to express materials. It can express all the commonly you know, all the commonly used shading models, including glTF PBR and OpenPBR and standard surface and all the others. It does have this pretty powerful concept of translation graphs that can help us a lot as we map between different models. OpenPBR is, you know, the focus on high fidelity way of standardizing materials. But there is some concerns there about consistency for real-time implementers. So I guess that's still an open question. glTF and glTF PBR is, you know, very compact and portable, and you know, there's certainly a lot of benefits with that. But one takeaway here is that we need to keep evolving these standards together. And then, yeah, make sure that we have cross communication between these different groups. So I think the Metaverse Standards Forum is a great way where we can all come together from these different groups. And there's also an ability to more directly contribute to MaterialX and OpenPBR, because Cardinal Software Foundation is open to everyone. So I think one thing I would encourage in particular is more of the real-time community to participate in those discussions, because the Cardinal Software Foundations comes from a film background, so there is a bit of a bias towards offline rendering and those type of workflows. So having more of the real-time community kind of providing their input to those groups, I think would be very useful. So that was it for my slides. So let's switch to Q&A and discussion.
Awesome, Hendrik, and thank you for updating that even since SIGGRAPH. So who has the first question?
So yeah, that was yeah. Thank you, Henrik. Every time I see you describe it, I understand a little bit more. So the of those various translations, obviously with the glTF hat on, so coming in and out of the various other formats, would you suggest that if we do have resources and effort, do we focus on translating in and out of standard Surface now or OpenPBR? Do you think it's the right time to kind of intersect with OpenPBR in terms of coming in and out of glTF?
Yeah, I think it would be. I think it's the right time to go with OpenPBR because we can always map from standard Surface to OpenPBR also. And hopefully that transition goes pretty quickly. I know we have pretty aggressive timelines for our DCCs to support OpenPBR, and I think it's the same for Adobe. So it shouldn't take that long before all the authoring tools have that. But even in the case where you have standard Surface today, you can map that to OpenPBR and then go to glTF.
Yeah. Okay. Yeah, that makes sense.
It would be in everyone's interest to at least keep all those mappings up to date. So every extension we add to glTF PBR, if we can make sure that those graphs going in both directions are updated as soon as possible.
Yep. Yeah. That's probably the most urgent thing, right, from the glTF side, is to get that updated.
Yeah.
Yeah. Yeah. Okay. Thank you.
So Henrik, how do you feel about just real-time hardware, like looking at mobile? Like, are you happy with the compute trends, or you feel it's going to be more and more capable?
Yeah, one thing that has come up, and I've had to correct myself a few times, is when we talk about real time versus offline, like the fact that you can do real time ray tracing on a lot of devices these days, and that's coming pretty quickly even on mobile. We should probably differentiate between rasterization and ray tracing or path tracing more so than real time versus offline. So I think that is changing. That I see a lot of movement on that front, and mobile devices having ray tracing cores basically, or hardware support for traversal and intersection. So that will probably help a bit because it's so much easier to implement some of the material aspects in a ray tracer than it is in a rasterizer. While it's doable, you have to go through a lot of tricks, and in some cases they break down and you get artifacts, and yeah.
Cool.
Yeah, we'll probably still have rasterization for a while, of course, but I think there's movement on that front.
Exciting time. Other questions? Sandy.
Yeah, getting back to actually what Neil was talking about with the shader translation. So I thought in your talk you identified sort of a missing, like, to go from, what was it, from standard Surface to glTF PBR. Like some translators, some are currently missing.
Yeah, it's glTF to standard Surface is the
So
one.
then, okay, so from so is that something that should be fed maybe to the Kronos tools group as something like that sounds to me like, the definition of a project that should happen. And is that something that we could sort of feed over to the tools group, Neil?
Yeah, I think so. But but rather than standard Surface, we should do it with OpenPBR, right?
Yeah, and yeah, there's not a whole lot. It's probably not more than a couple of hours extra work to add both of them if you want that in the meantime. But
Yeah.
Yeah, there needs to be one way, and I'm sure there are, but especially for the interop project, that would be useful. Because of course it's more common that you go from USD to GLTF in a publishing workflow, but as we've discussed many times before, you also might like aggregate GLTFs into your USD project. And depending on, you know, what workflow you're talking about, you might want to up convert that to OpenPBR.
Yeah. So I mean, so that's actually, sorry, Sandy, go ahead.
No, so that's my question maybe for Neil is, so like what has to happen to get a project going, and, you know, who funds it and who does the work, of course, you know?
Yeah, well, you know, we have budget coming up, so we can, you know, decide how we spend the budget at Kronos, or if you wanted to co-fund it, you know, here. But you raise a good point, Henrik. I mean, presumably a lot of the tool chains that we're talking about, you know, in the first half of the meeting, we were talking about the USD glTF interoperability project. Presumably, a lot of those tool chains absolutely are going to need OpenPBR to glTF PBR and vice versa, right? We would expect that to come up pretty high on the list. So we're going to get there one way or the other. We're going to need that bi-directional translation. And OpenPBR, again, would be the preferred way for glTF to reach into the USD universe.
Yeah.
Correct? Yeah. Yeah. So, Sandy, let's put it on the list on the next glTF meeting.
And I just wanted to mention that it's totally ridiculous talking about ray tracing on mobile platforms. That's just like, give me a break.
Other comments, questions for Henrik? So Henrik, I have a question for you, or maybe even for Ed, who I saw on the call. So I believe within MaterialX, there's also a glTF PBR node, right, where you can put the glTF PBR parameters. But maybe we need to do some updates to it. But do you know, is there any adoption of that beyond like glTF workflows? Like, or have other folks picked that up?
I don't know, Ed, if you have more insights there, but I think there's quite a few that is using it, but I can't speak for them. So, but I know we've had some presentations earlier on some of the other like tooling around glTF and so on. I think, when we had the JUC presentation, you know, Paolo also highlighted the importance of using MaterialX there to represent the glTF PBR as you go into USD, because you can't, if you use the previous surface, you will lose a lot of parameters. So I believe that the JUC is using that, but I can't speak for that project. But in those types of workflows, it would seem natural to use the MaterialX glTF PBR node.
Yeah, just to agree with that, we did confirm in the source code of the JUC converter project that it is using that glTF PBR node. And I think that's the right answer for any asset that was acquired as glTF and you're looking to temporarily move it to USD. The glTF PBR node is sort of the first stepping stone into that world. And then from there, if you want to bring it all the way into OpenPBR or something like that, you can use one of the translation shaders. But you have to get to MaterialX first, and to do that, you need the glTF PBR node.
So may I suggest maybe we wrap up the official part of the meeting, and then if folks have time and want to stay on for the water cooler, we do that? Cool. All right, well, Henrik, thank you once again for the presentation.